Okay, I'm on page 12 of your packet. You guys know what a sequence is and what series is, and we're going to be going over what it means to be geometric. So this is a type of sequence. We learned a couple days ago that an arithmetic sequence meant we're adding or subtracting by the same amount each time. That's the pattern, and whatever we're adding by is called the common difference. And for geometric sequences, we're going to be multiplying by a fixed amount or dividing. And that whatever we're multiplying by is called the common ratio r. So I want you guys to go back to when we're trying to figure out what a function is. When we had our y values, whenever our y values were multiplying down the line, then we knew that it was an exponential function. So look at my geometric sequence here. It takes an exponential function, whereas our arithmetic sequence, where we were adding or subtracting by the same amount by the pattern, it was a linear function. So this goes hand in hand from what we learned a couple units ago. So notice the non-linear nature of the scatter plot. So it's actually an exponential, whereas our other one was a linear. Okay, let's look at a few examples. So in this geometric sequence, if I'm trying to find the common ratio, I notice the pattern, I'm multiplying by 2. So since we're multiplying by 2, I know it's geometric instead of arithmetic, or exponential instead of linear. So it's just calling it something different when we're talking about sequences, okay? So that means I'm multiplying by 2. Looking at this example, I'm multiplying by a negative 2. Negative 11 times a negative 2 gives me 22. 22 multiplying by a negative 2 gives me negative 44. Negative 44 multiplying by negative 2 gives me positive 88. So in this one, I'm multiplying by a negative 2. And my third example here, I'm multiplying by 2/3. Multiplying by 2/3. Multiplying by 2/3. Multiplying by 2/3. Alright, so that's how we figure out our common ratio. Let's flip the page over. So we have two equations for geometric sequences and series, just like we had two equations for arithmetic. So this is when we're talking about the sum, and this equation we use for everything except the sum. So whenever the question is talking about the sum, use this equation. When it's talking about anything else, use this one, okay? And I will be giving you guys these formulas on the test. Okay, numero uno. Find the common ratio for the sequence. So common ratio, I know I'm multiplying by a certain amount. So if I go from 6 to negative 3, I know that 3 is half of 6, so that means I must be multiplying by 1/2. But this is a negative 3, so that means I must be multiplying by a negative 1/2. And just to check, negative 3 times a negative 1/2, well, let me see, that would be negative 3 over 1 times a negative 1/2. Multiply across, negative 1 times a negative 3 is a positive 3 over 2. Okay, so I'm good there. So that means my common ratio that we say is r is equal to negative 1/2. Find the common ratio of the sequence given by this formula. Okay, well here I have a formula. Let's go back to this one. So I'm comparing this. Common ratio is equal to r. So I want to find out where in this equation r is equal to. Well, here I have a1, that's my initial value, right? R is our growth factor, so what we're multiplying by each time. So that means r is directly below my exponent. So the number directly below my exponent is 3. And that makes sense. I'm multiplying 3 times 3 times 3 times 3. My initial value is 5. So everything should kind of be clicking at this point because this is very similar to our exponential unit. Find the 7th term of the sequence. Okay, first I want to make sure that this is geometric. So 2 times 3 gives me 6. 6 times 3 gives me 18. 18 times 3 gives me 54. Okay, so it is geometric. I know since I'm multiplying by 3 each time, r is equal to 3. And I'm trying to plug into this equation. Okay, so I'm going to write this equation down. an is equal to a1 times r to the n minus 1. Well, I know r is 3. My first term here, a1, is equal to 2. So I have a1, I have r, and now I need n. Well, if I want the 7th term, that means I want a7, so n is equal to 7. So I have everything that I need for my equation here. So I'm going to plug in a1, I said was 2 because it's the first term of the sequence. R was 3, so I'm going to just put this in parentheses here. And then I have to the 7 minus 1. So I'm going to subtract first. I'm going to do my 7 minus 1, which is 6. So now I have 2 times 3 to the 6th power. So now I have to do 3 to the 6th power. So 3 times 3 is 9. 9 times 3 is 27. And then if I know 3 to the 3rd power, I just did 3 to the 3rd power is 27. If I want 3 to the 6th, I can just do 27 times 27. So I'm going to do that. 27 times 27 gives me 9, 14, 18, 14, 5, 9, 12, 629. So I'm going to have 2 times 629. So I get, for the 7th term, 1,258. All right, let's go to number 4. Find the 11th term of the sequence. I still need r, a1, and n to plug in to this formula up here. So I know that a1 is equal to 1 because that's my first term. So that's the easiest for me to figure out. Now I want to find out, I know n, the number that I'm solving for, I want the 11th term, so n is 11. Now I need r, which is what I'm multiplying by each time. So to get from 1 to negative 1/2, that means I had to multiply by 1 times negative 1/2 to get my negative 1/2. Negative 1/2 times negative 1/2 gives me a positive 1/4, etc. So I know my r is equal to negative 1/2. So now I use all 3 of these to plug into this equation. So I want a11, I'm using the same equation that I used in number 3. a11 is equal to, my a1 was 1, times my r was negative 1/2 to the, now 11 minus 1. So I'm going to subtract first. 11 minus 1 is 10. So I'm going to get 1 times negative 1/2 to the 10. Now, because I have a fraction here, I'm going to distribute that 10 to the numerator and the denominator. Distributing here, distributing here. It doesn't matter if that negative goes on the 1 or the 2. I'm just going to put it on the 1. So now I'm going to have negative 1 to the 10 over 2 to the 10. Negative 1 to the 10, since this is an even exponent, that means I'm going to come out with a positive 1. And 2 to the 10, let's see, 2 times 2 is 4, 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. So 2 to the 5th is 32. And if I want 5 more 2's, I can do 32 times 32. $724. So I get 1 over 724. And the last one, if I want a 8 for the sequence, my A